So we're going to review this test. So number 1, let me write this down. Oops, I got to change this. Come on, where is it? There it is. All right, let's try this one more time. There we go. All right, so what is it? 17, and then 6, and then some more 3s. So to change the scientific notation. Scientific notation, you need one number to the left of the decimal. So if your decimal right here, that's just a regular, that's supposed to be a 6. A lot of swooshy things here. That's a 6. All right, so here's your decimal, the way it sits right now. Where do we want to move the decimal? Between what and what? The 1 and the, whoops, I missed it. Let's try this again. There it is. Between the 1 and the 7, all right? So here's what we do. We got 1.7 times 10, and now you got to count to see how many places that you moved it over. You don't just count the zeros, count how many place values. So you went to here, that's 3. You went 3 more, that's 6. You went 1 more to get to there, that's 7. This is a big number, so it's 10 to the what? Positive 7th. Oh, I'm sorry. Yes. That was my bad. It's my bad. No, it's good. I need to know. No, that's fine. So it's 1 point, oops, what's going on? 1.76. Sorry about that. I was thinking that was a 0 because my writing was so bad. Yes. If it was a 0? Oh, if that 6 was a 0, yeah, it'd just be 1.7. But I just couldn't read my own writing. I thought that was a 0, even though I even said that's a 6. It's not a 0. All right. Number 2. How many zeros? 3. So 0.1237 Again, scientific notation, we're going to take that and we're going to move that in between, boom, right there, the 7 and the 8. So it's going to be 7.8. Now, this is a small number. It's less than 1. So what's my exponent going to be? Times 10 to the negative. That's right. And again, it's not just how many zeros we have. Sometimes it actually works out. All right, it's the same amount of zeros. But it's the place values is what you want to count. So you go 1, 2, 3, and then 1 more. That's 4. So it's 10 to the what? Negative 4. Okay? I had some weird stuff on this. Okay? I had people not even putting times 10 to something. I don't know where you were this whole year, but that's something that you got to know. All right, number 3. A lot of people looked at this during the test themselves. They said this already looks like it's in scientific notation, but it's not in scientific notation. It looks like it because it's got times 10 to something, right? So did I give you a copy of the test? Did somebody tell you what we're doing? Okay. Let me get that test. Where did I put it? Oh, it's right up here. All right. Can you pass that back to Sophie? All right. Let's see. Why is this not in scientific notation right now?
Because it's not between the 3 and the 2.
Right, because the decimal, right, is right here. You can't have 3 numbers before it to be in true scientific notation. All right, it can't be right here. It's got to be here. So I need to move it right there. So I'm going to have 3.23. Now, watch what we do. We put times 10. Now, we moved it to the left. So this one goes to the right, okay? Because we took a big number, we made it smaller, all right? And so we're going to have to take this, we're going to have to make it bigger, right, to compensate for it, all right? So if this goes to the left 2 places, this goes to the right 2 places. How do I write to the right 2 places of 5? Well, it's plus 2, right? But it's 7, okay? It comes out to 7. Everybody got it? Wait, what?
Oh.
Okay. Number 4. When's this class over, by the way? 45. Wow. Okay. Yeah, I think we might be able to get finished. Yeah, it's Wednesday. I always forget the Wednesday schedule. All right. So 4. Here we go. It's 0.0317 times 10 to the negative second. Again, it's not in scientific notation. It kind of looks like it because you got the times 10 to something, but it's really not in scientific notation right now. Where does the decimal have to go? Between the 3 and the 1. So it's got to go there. So it's going to be 3.17. Now, what we did is we made that smaller number a little bigger, so I'm going to have to make this number, I'm going to have to make it what? Smaller. So if this went to the right 2 places, this goes to the left 2 places. What's 2 places to the left of -2? It's -4. That's how you do that. All right, a couple more of these. Well, a few more of these. 5. Now we change it to standard form. All those other ones was in scientific notation. Now we're taking scientific notation and we're changing it to standard form. Standard form is just a number, all right? Just could be a decimal, could be a fraction, or no, I'm sorry. Yeah, I guess a decimal could be a fraction. Could be a whole number, could be an integer, whatever. All right, so here's what we're going to do. 3.7 times 10 to the 5th. This means we're going to move the decimal place. How many place values? 5 place values. Okay, that doesn't mean we put 5 zeros on there, does it? It means we move it 5 places to the what? It's times 10 to the positive 5th, so we move it to the what? To the right. This means we're taking this times 10 to the 5th, means we move it to the right. Question? All right. So I'm going to put a 3 and a 7. So I moved it 1 place to get it to here, correct? If I move it 5 places, how many zeros am I going to have? I'm going to have 4 zeros. Everybody see that? All right. So there's no decimal on this. It's just that. If you want to put a comma, it's fine. Put the comma. Separate the 3 zeros. You don't need the comma, but that's what it would be. 370,000. All right. Let's do another one. Number 6. It's 3.7 times 10 to the 4th. -4th. 3.7 times 10 to the -4th. Again, read the question. What's the question say? Change it to what? Standard notation. This is not scientific notation. We change it to standard notation. Several of you gave me answers for 5 and 6 in scientific notation with times 10 to some power. That is not standard notation. Standard notation is just a regular number. This is just a regular number, isn't it? That's what we're trying to do. It could be a decimal, all right, but it's just a regular number. It doesn't have times 10 to something in standard notation. So what are we doing here? We're going times 10 to the -4th. That means our decimal place is going to go in what direction now? Left. How many places? 4 places. So if it's a positive, it goes to the right. If it's negative, the decimal goes to the left. So if I move it 1 place, that's 1. But then I got to have how many zeros then? So I already moved it 1 place to get to here. Okay, if I'm going to go 4 places, I'm going to have 3 zeros, aren't I? 1, 2, 3. All right, 3, 7. Again, it was right here. We moved it 4 places to the left. 1, 2, 3, 4. And that gives you 0.00037. That's in standard notation. All right, it's just a regular number. Standard notation is just a regular number, if you want to think of it like that. All right, number 7. It's kind of the same thing, except you're doing like 3 of them, and then you're going to do some stuff. What am I trying to push? N. All right. So 640,000. This is what? 2,700,000. And this is 120,000. All right. Read the instructions. What's it say right off the bat? Write what? Write each numeral in scientific notation. So don't just throw that in a calculator and give me an answer. I've got to see that these are in scientific notation. I may have missed it. I may not have missed it. I can't even remember if you did it or not. But anyway, we want to change them into scientific notation because that's what our instructions tell us to do. Let's do it a little quicker than we did before. So this is going to be 6.4 times 10. How many places did we move it? There's 3, 4, 5, correct? So this is 10 to the 5th, positive 5th. All right, and now I'll just put a dot for times. I'm going to have, try this again. I'm going to get 2.7 times 10. Again, how many places? 3, and then 6, right? So times 10 to the 6th over. And then this is going to be 1.2 times 10 to the, there's 3, 4, 5. That's a big number, so it's a positive 5, okay? At this point, I can't really tell if you use your calculator or not, and I don't mind you using your calculator, but I'm going to show you something super easy. Do you see something that can cancel out right away? What? 10 to the 5th, right? So the 10 to the 5th cancels with that 10 to the 5th. Now I don't even have to deal with that, right? It's the one less thing I have to worry about. So what I'm going to do, let's see, what did I do on this one? There we go. What I'm going to do is put this in the calculator. I'm going to put this times this. So 6.4 times 2.7, and then I'm going to divide it by 1.2, and I actually get 14.4. When I put those three things I circled in the calculator, I get 14.4. Everybody see that? Okay. I just put in a calculator, 6.4 times 2.7, and then I divide that by 1.2. All right? And I get 14.4. Now, what's my times 10 to the thing? What's left over? Times 10 to the 6. But some people left it, and I had to mark it wrong. Sorry, but I had to because this is not really in scientific notation. Why is it not in scientific notation? Because the decimal, that's right. So I'm going to have to move it one place to the left, which gives me 1.44 times 10. If I move that to the left, I move that to the right, and then that is the answer I'm looking for right there. Okay? Now again, if all you show me is 1.44 times 10 to the 7th, all I'm thinking is that you just stuck that in a calculator and got that, okay? I need to see this. I need you to change them, all three of them, into scientific notation, and then you can go ahead and use the calculator for it. This one worked out pretty nice because they canceled out. Worked out pretty easy. 8 is kind of the same problem, except it doesn't cancel out quite as nice as 7 did, but it works all right. Tell you what, instead of writing the problem down, you have it right in front of you. Do you mind if I just write what the scientific notation is? All right, so if you're watching this on YouTube, you'll have no idea, but everybody else got their test. Well, I tell you what, let me just write it down because there's a couple people that still aren't here today. So I'll write down what the problem said. So it's point. How many zeros do we have there? 1, 2, 3, 4, 5 zeros and a 1, 3. 1, 2, 3, 4, 5, and then a 1, 3. All right, and then we got what? 1, 2, 3, 4 zeros. So point 1, 2, 3, 4 zeros and a 9. And then 3 zeros, 3 nines. So point 1, 2, 3, 3, 9. All right, there we go. So first thing it says is change the scientific notation. So the first one I'm going to put 1.3 times 10 to the, let's count, 1, 2, 3, 4, 5, 6. And they're making a smaller number, right? So it's to the negative 6. See, that's a small number, so it should be times 10 to the negative power. All three of these are decimals, right? When I say small number, I'm meaning it's less than 1, okay? So let's do this. Then we times it by 9, right? Because I moved my decimal all the way to here. So how many places was that? That's 5 places, is that right? And it's to the negative 5th. All right. And then I got 3.9 times 10 to the what? 3, 4, negative 4, is that right? Okay. Okay. Here's what I would do. You could actually simplify this without a calculator, to tell you the truth. 1.3, 3.9, how many times do they go? How does 1.3 go into 3.9? 3 times. And then 9 and 3, right? 3 goes into 9 3 times, so you have a 3. All right? So you could do that in your head. But if you want to put it in a calculator, I'm fine with that. Now, let's see what we have here. What is this and this going to give you? Times 10 to the what? Times 10 to the 11th? Negative 11th. That's right. So that's the top. But what am I going to have to do with this? I could just subtract, but I'm going to flip it to the top. And I'm going to make it 10 to the what? Positive 4th. So this is going to be 10 to the positive 4th. This is how I would do it. There's several ways you could do it. This is just how I chose to do it. So the 3 stays the same, times 10. 10 to the negative 11th, 10 to the 4th. What do? We add the exponents. Negative 11 plus 4 is, how about negative 7? All right. And there you go. Is that the answer? I didn't tell you what the answer is. Yep, I'm looking at it. That's what it is. All right, number 9. Now we're starting to do some real algebra stuff here. Now remember, the test is going to be problems that look just like what I just did, except the numbers are going to be different. That's it. Okay? It's going to be same type of problem.
So for the corrections, we only do the ones that we.
You're taking the test all over again.
Oh, so this doesn't count.
Correct. I thought I made that clear at the beginning. At the beginning, I said, I'm not counting this test. All right? I said, I'm not counting it. Is this you? In yellow? Really? Okay. I said, I'm not counting this test. I gave it back to you. You're not doing corrections on it tomorrow. You're taking a brand new test from scratch. Everybody hear that? All right.
Are we taking that tomorrow?
Taking it tomorrow. That's tomorrow. All right? And I will grade that no matter what you got on it. I am going to grade it tomorrow. All right, let's keep going. Let's go a little faster. Quarter of, is that what you said? 12:45? Oh, my, time is fleeting. I'll tell you what, let me do this. Let me read off all the answers to you, because I don't think there's no way I'm going to finish all this today. So let me read off the answers, okay? So write them down. So we are on number 9, right? Okay, so here we go. What's going on out there? All right, number 9, x is equal to 6. Number 10, x is negative 8. Write it down. Number 11 is negative 11. Negative 11. Number 12 is negative 7 over 3. Negative 7 over 3. Number 13 is 1.7. You can keep that as a decimal since the problem had decimals in it. So it's 1.7. Number 14 comes out to 2,500. 2,500. 2,500. 2,500. Number 15 is 3. X equals 3. Number 16, x equals negative 2. Negative 2. Number 17, you had to solve for x, and it's y minus b, and that is over m. Y minus b over m. Number 18, you had to solve for capital B, and it's 3v over h. B equals 3v over h. Number 19, you had to solve for f. F is equal to 9/5 times c. You got to make sure the c is either like real big right next to it, or it's on the top. You cannot have c on the bottom. That means something completely different. So it's 9/5 c, and then plus 32. So 9/5. If you wrote 9c over 5, it's the same thing. I would accept it. But you can't have the c on the bottom. You got to make the c like really big out front or next to it, and then a 9/5 in front of it, and then plus 32. Okay, number 20. Some of you came close, but you missed it a little bit. Let's make sure we do this before you guys leave today. Number 20, you had to solve for L, and it's 2s over n. And then after that, you have minus a. So the a is not part of the fraction. Everybody hear that? All right. Now, I think one person put 2s minus an, and the whole thing was over n. And I gave it to you because that is correct. It's technically not completely simplified, but I did give that to you. But I want it like this. I want it 2s over n, right? And then after that, it's just minus a. That's how I want to do that one. Let's do that one right now since we're talking about it. Is that all right? So you can do this one, right? Minus 1, that's a 2. Divide by 2, x is 1. Big deal. All right, so let's do number 20. S equals n times a plus L. It's an L over 2. And we're solving for L. Solve for L. All right, first thing I'm going to do is this. Everybody watch. First thing I'm going to do is get rid of this 2 because everything's being divided by this 2. So let's get rid of the 2 right off the bat. How do you get rid of something that's being divided? Multiply. So I multiply this by 2. I'm not going to show it, but I multiply that by 2. It'll cancel out. What do I do to the other side? Multiply that by 2. Everybody got that part? That's real simple. Everybody, every single person in here should get that first part of it. All right, now you have this n is being multiplied by all this stuff in the parentheses. So let's get rid of the n first. So it's being multiplied. How do we get rid of something that's being multiplied? We divide. So if I divide this by n, they cancel out. What am I going to have to do over here? divide that by n. So that n will cancel, okay, and you got this over n. Let's write it a little bit nicer. Okay. I'm going to solve for L. Got to get that by itself. One more step and we're done. What's the step? Subtract what? Right, it's not divide by A because A is being added to this, okay? So we subtract an A from both sides. You know that'll cancel out. Now here's where the problem, on some people, here's where the problem occurred. I'm going to rewrite that 2s over n. And if I subtract an A, I don't put it on the top. This is completely by itself. This is A over 1. Look, 2s minus A over n is not equal to this right here. They're not the same. Okay? Just putting an A on the top, they're not the same. Now, if you put an, that is the same because look, 2s is over n, correct? Just like we had right here, minus an over n. But what happens to the n's? They cancel out. I'm left with an a. Do you see why I said it wasn't really simplified? Okay, so technically I probably shouldn't even give you that. But this is the way I want it right here. It's circled. That's the way I want it. It'll be similar to that. It won't be the exact same problem, all right? But it'll be something similar to that. All right, tell you what, we only got like 4 minutes left. Let's pick and choose. Which one on here do you really, what about one of those fractions, 15 or 16? Was that a good one to do? 12?
Yeah.
I think I can do both. Let's do 12 super fast, and then I'll do 16. All right? Maybe I can do it. So if it was already written, I could probably do them, but I got to write it down. 3x plus 5. Oops. Come on. When I try to write too fast with this mark or this pen, it acts crazy. Negative 6x plus 2 times x plus 2. All right, here we go. I'm going to go through this very quickly. This is negative 4x. This is minus 6x. This is minus 10. A lot of people are not distributing that negative. You have to distribute the negative through here. Minus 6x, and then distribute the 2. So that's a plus 2x plus 4. Add like terms, that's a negative 10x minus 10 equals, add like terms here, that's negative 4x plus 4. Let's do this. Let's add a 10 to both sides, or 10x. Let's add a 10x to this side. Why would I put it on the right side? What's the purpose in that? Yeah, just so it's positive. That's the only reason. You could put this negative 4x over here on the left. So x is on the right, so let's get rid of this 4 right here, right here. They cancel. This is negative 14. That cancels. This is what? 6x, correct? All right, divide by 6, divide by 6. You've got, I marked a lot of people's problems wrong because they didn't simplify. You got to simplify the fraction, all right? So what goes into both of those? 2 does. 2 goes into that 3 times. 2 goes into that what? 7 times. So what's x equal to? Negative 7 over 3. And that's your answer, okay? Everybody got it? All right, let's do 16. Do I have time for this? We'll see. 2x plus 3 over 3. Plus 3x minus 4 over 6. X minus 2 over 2. All right, first thing we do is get rid of the denominators, find a common denominator. That would be 6. So I'm going to multiply this by 6. I'm going to multiply this by 6. And I'm going to multiply this one by 6. Notice I put those in parentheses. They didn't originally have parentheses, but I put them there because that 6 is being multiplied by that whole entire numerator. So that's what I do. But I'm not going to distribute right now. The whole reason I multiplied everything by 6 is so that the denominators can cancel out. That 3 goes into 6 twice. This 6 goes into it once, just cancels out completely. This 2 divides into that 6 3 times. All right, let's do this distributive in our head. So it's 2 times 2x, which is 4x, plus 2 times 3, which is 6. Plus, there's nothing to distribute here because it canceled out. And then we distribute the 3 through this, 3x minus 6. And now we add like terms. What's that? 7x plus what? 2 equals 3x minus 6. Subtract a 3x from both sides, what do you get? 4x. Subtract a 2 from both sides, what do you get? Negative 8, right? Subtract a 2, it's negative 8. Divide by 4, right? Divide by 4, x is negative 2. That's your answer. Simple as that. A lot of you guys just made little mistakes, okay? And I saw it. I forget what problem it was. There was a problem where you didn't distribute the negative. Like, I don't know what problem it was. Was it 11? Okay, yeah. So you had a negative and then a parentheses, 3x plus 1. A lot of you went negative 3x, what? Plus 1. That's enough to get that problem wrong. You got to take that negative and distribute it through both of them. All right. Yeah, that's what you're using it to study from. Use it to study from. Tomorrow you're taking the test from scratch, using that to study from, and I'm going to try my best to put the rest of them up on YouTube, but at least go back on YouTube and watch these.